Let's look at how to create a hypothesis test for one average. I'm using the same four-step process that I always use. Step 1, state the hypotheses. Step 2, model. Step 3, calculate the p-value. This is where I compare the sample data to the claim. And in step 4, I have my conclusion. When I'm dealing with averages, my null hypothesis is going to look like mu equals whatever number is being claimed. In this case, Fruitastic is claiming that there are 7 fruit snacks per pouch. I think the actual value is less than that. For alternative, I'm going to have less than 7. This will be a left-tailed test because I'm testing for less value. I sampled 41 pouches, so as a reminder, the degree of freedom is the number of samples minus 1. So 41 minus 1 gives me a degree of freedom of 40. My model, X bar, that's the name of the model, so I'm not actually plugging in anything there. T, and I have a degree of freedom of 40. Whatever number I have here for the null hypothesis, I'm plugging in for my center. So I have a center or a claim of 7. My standard deviation is this 2.2 divided by the square root of 41 number. I'm using t-scores because we are provided a sample standard deviation. If I had a population standard deviation, I would be doing the same thing right now, but I would be using z-scores instead. In fact, the models are nearly identical. So I've typed this into my calculator and I got a standard deviation of 0.344 if I round a little bit there. Step 3, p-value. So I actually got an average of 6.7. So my curve and the student t-distribution looks a lot like a normal curve that's just a little bit shorter and a little bit squattier. So center is 7. I'm counting by 0.344 or so. And I ended up with the p-value is the likelihood of my sample average is 7 or more extreme, means I'm testing for that or less. Oops, sample average of 6.7. So on my curve, the claim was 6.7, but my actual data was a sample average of 6.7. And I'm testing for less, so my p-value is going to be the size of this small shaded in tail. Well, not that small. This actually looks considerably large for a p-value, but at least it's not the whole curve shaded in. I'm going to find my test statistic or my t-score, and I'm going to do this the same way I would find a z-score. I'm going to take the sample value that I care about minus the center of my model, and I'm going to divide this by my standard deviation. In this case, I have 6.7 minus my center is 7. My standard deviation is 0.344. Typing this into a calculator, I end up getting a t-score, which works really similarly to a z-score, of negative 0.898 or so. Now with z-scores, I had been rounding those things to 2 decimal places so I could look them up inside of a normal table. I don't have to worry about that as much here because I'm going to use technology to look up these t-scores. And the setup for this is going to be p-value. I'm going to use the t-distribution and something called t-CDF in my calculator. I'm going to put in whatever my low t-score is for my shaded in region, whatever the high t-score is for my shaded in region, comma, whatever the degree of freedom happens to be. I want to go over the setup before how to find this thing inside of your calculator. Looking at this shaded in region, the low value, that's the left side. While this low value, it keeps going forever, pointed in this negative infinity direction. So my left part of that shaded in region is negative infinity. I stopped shading at 6.7, but it wants the t-score for that. The t-score for 6.7 is this negative 0.898. So I'm shaded from negative infinity t-scores, so really, really far to the left side, all the way up to this t-score here of negative 0.898. My degree of freedom was 40. To find this in my calculator, if I'm on a TI-83 or an 84, I'm going to go second, and then I'm going to choose the VARs option, and I'm going to choose the thing that says TCDF. If I'm in a TI-89, I'm going to go into apps, and then I'm going to choose the option for stat list editor. And inside of stat list editor, I'm going to choose my distributions. So apps, stat list editor, distribution is coming up at the top there at F5. If I'm doing this in Geogebra, I'm going to open up my probability option. And I'm going to choose the T model, and I'm going to shade in my curve. Let me show you how to do this using the TI-83 and 89. So I'm going second VARs. I'm choosing TCDF from negative infinity, and I can just type in a whole bunch of 9s for negative infinity. My upper value, my high t-score was negative 8.9, and then my degree of freedom was 40. This gives me a p-value of 0.187 or so. That's a pretty large p-value. In my TI-89, I'm going to go to F5 for distribution, and I'm going to choose TCDF. Now, my TI-89 actually has an infinity button. It shows up in green there above catalog, so I could hit negative second infinity to pull that up if I would like. My upper value is at negative 0.898. My degree of freedom is 40. When I do this, it's still going to give me the same CDF value of 18.7%. So I'm not seeing a sizable difference if I use actual infinity or just a whole bunch of 9s. Since my p-value is larger than my alpha, using the neutral alpha level of something like 5%, I would fail to reject the null hypothesis, which means I do not have evidence that the average number of fruit snacks is less than 7. Finally, I will show you how to do this inside of Geogebra as well. I'm going to go to my desktop here, and I'm going to choose the option for Geogebra Classic. And I'm still going to have the option of putting in my t-score and my degree of freedom. So on the side here, when it opens, I'm choosing the thing that says probability. Instead of this normal distribution, I want to choose the student t distribution. The student distribution is the t distribution. You'll notice how it still looks like the normal curve. My degree of freedom was 40. And I can choose how I want this thing shaded. This button allows me to shade to the left. This button would be shaded to the right. I want it shaded to the left. And my t-score was negative 0.898. shade it to the left with that negative there. Great. And when I do this, it gives me a p-value of 0.1873. I'm getting the same p-value inside of Geogebra that I got using my graphing calculators. So use whatever technology you have available while you're going through the problems. Again, the 4 steps, pretty much the same as 4 steps of any hypothesis test. I have my hypotheses, my model, my p-value, and my conclusion. When I'm finding these t-scores, I'm still treating them like z's, where I'm just doing value minus center over standard deviation. If my p-value is low, the null must go. If my p-value is high, I would fail to reject the null hypothesis.